I worked, I'm a mechanical engineer. I have a master in mechanical design, and I worked in astronomy, in telescopes and radio telescopes, and I have to several instruments for many optical telescopes. And I do here is a speckle interferometer. With this instrument, we found many new stars in binary systems and multiple systems. And we have two types of camera. Here is a visible camera and infrared camera. And also I worked here in the radio telescope, designing different kind of mounts. Okay. Well, our laboratory is at the UNAM. The UNAM is the National Autonomous University of Mexico. And here we are developing instrumentation. Right now we have a project with for a biological nanosatellite experiment. We developed a software-defined radio based on FPGAs. Also, we developed onboard computers, photovoltaic power systems, cameras in HD with this resolution, 30 megapixels, 30 meters per pixel, sorry. Also, we developed mechanical structures, we developed automechanical systems, we developed inertial wheels, we designed a solar simulator, and also we are developing a magnetic field simulator, and we design fault tolerance electronic systems in our laboratory. So I'm going to tell about our project. We were designing a remote sensing camera. It was a collaboration with Russia. We were working the UNAM, the Institute of Aviation of Moscow, and the Lavochkin in Greece. So we have these parameters of our camera. We have two sensors, two cameras with two sensors CMOS. Our resolution is 5 megapixels. We control it with FPGAs, and our total mass is more or less 6.5 kilograms. And we, for this project, we are developing fault tolerance techniques based on the configurations to achieve requirement level of reliability for space instrumentation. These are the fields of view of the camera. We have, as I told you, we have two fields, two sensors. The first one is about 8 kilometers per almost 40 kilometers, and the second field of view is 120 kilometers per 100. So I'm going to start with my research that is about the adhesives. We know that the conditions there are not the same here in Earth than in space, but we don't find an equation that predicts the thermal stress in many components, and this is so important because many optical components can failure. So we need to predict it. The camera I showed before, we saw that we have a problem, so we start searching about the information, and also we noticed that in industry they are being more adhesives using it. So we noticed that they are adhesives using in the automobile aircraft, spacecraft, and satellites. They are using more and more. So these are the principal problems of the adhesives: the stiffness of the joint, the stress caused by thermal expansion coefficients. We have two thermal coefficients because they are made of different components and the possible contaminations of this joint. Also, for space applications, we have to follow this standard that I mentioned here. And for space applications, the adhesive have to pass this standard that the total mass lost will be below of 1%, and also the collected volatile condensable material have to be below 0.1%. If you want to know more about this, here is the web page. And well,